Hi everyone, today we'll be working on question number 17 on LeetCode called letter combinations of a phone number. So if you ever used a old phone before, then you know that every number in a number pad can be represented as either 3 or 4 different characters. So for example, 2 can represent A, B, or C, 3 can represent D, E, or F, and so on and so forth. And they use those to represent words during a info commercial or something like that. So we basically want to get all the different combinations based on a phone number. So for example, 23 would get all combinations of 2, which are A, B, and C, and all combinations of 3, which are D, E, and F, and make and get all the possible combinations. So since we want all possible combinations, this is a backtracking question. So let's initiate a temporary array to be, not array, string to be updated. Let's have a result hold everything. And let's map out every single number to their respective letters. 4 is G-John. 6 is L. Cool. So to know what letters we're actually using for this question, we can call something called data, which will hold the letters that we use. And we say for let digit of digits. We want to push in into our data the mapping of that specific digit. So for the example of 2, 3, we'll be pushing A, B, C, and D, E, F. Cool. So let's write down how we're going to backtrack now. So when we're invoking the backtrack, I'm going to be using 4 inputs. We're going to be using the temp, the temp string that we'll be updating. We'll be using the data that we have, and we're also going to be using what I like to call current level, which starts at 0, and end level, which ends at digits.length. So the idea behind the current level and end level is that we're going to increment the current level every single time we recurse back into this function. And the reason why we want to go up 1 is because we want to take 1 letter from the first set in data and then 1 letter from the second set in data. So we use this to traverse the sets in data. So let's check this out. Love. So we're going to have our if function where we're just going to push temp return. We're also going to have our for function, which is going to backtrack with the temp, the data, the current level plus 1, and the end level stuff. Cool. So let's write this out. So first off, let's write our for loop. We can say I equals 0, I is less than data current level. That's correct. Yep. That way. And I plus plus. So we're going to be iterating over this string, and when we recurse, we're going to be iterating over this string. So that's how we get our different combinations. We're going to add the current letter to our temporary string. So we're going to add current level I, and then after we recurse, we always want to pop it out, so we can say temp is temp.slice from 0 temp.length minus 1. If you've seen my other backtracking videos, you'll know that this is basically the operation at the end to backtrack. We're removing 1 character at the end and trying over again. Cool. So then our if condition here can be if our temporary string is equal to the n level, then we push it in. So the reason why is because if our temporary string is the same length as the number of digits that we were originally given, that means it's a valid combination. So for example, 23 can be represented only as 2 characters, no more than that. So that's how this if statement works. So let's invoke this. Oh, sorry, we already invoked it. So let's just return the result and see if this works. Works just fine. Oops. Let's talk about the edge case. So if the digits is empty, we just want to return empty string. Oh, sorry, empty array. Cool, and it works just fine. So let's talk about runtime for this now. The entire runtime for this is going to be still O of n factorial, where n is the number of digits, because we're trying every possible combination. With that, I think that ends this question. I'll be putting a link to the question as well as my GitHub down below, and I'll see you guys next time.